Okay, let's talk about velocities. Notice in this one that everything's connected by a belt, so that means the linear velocities are going to be the same. So the first thing I'm going to do on A is, if I know the crank wheel is turning at a rate of 1500 revolutions per minute, that is my angular velocity. So to find the linear velocity in centimeters per minute, what I would do is I'm going to get my 1500 revolutions per 1 minute, and now I'm going to multiply by my radius, which was 15 centimeters. So 15 centimeters over 1. Now, right now, I am kind of in a mixed setting, so what I need now do is get rid of revolutions, so I can convert to centimeters per minute. I already got the minutes there, but I need to get rid of the revolutions. So I'm going to multiply by 2 pi. Radians is 1 revolution. The revolutions cancel, and so as far as A is for the first part, the centimeters per minute, we are looking at 1500 times 2 times 15, which is 45,000 pi centimeters per minute. Now, and you can multiply that out, but to go to meters per second, well, there's 100 centimeters in 1 meter, so 1 meter is 100 centimeters, and what I like to do is I like to cancel things out as I'm moving across. So right now I'm in meters per minute, so to get rid of the minutes I will multiply by 1 minute is 60 seconds. And the minutes cancel out, so now I am in meters per second. And I will end up with 15 pi over 2 meters per second. Now, on part B, determine the angular velocity in revolutions per minute of the alternator and the water pump. I'll just do the alternator. Well, to go from linear velocity to angular, I divide by the radius, and so I end up getting the angular velocity is equal to the linear velocity times 1 over my radius. And so what's going to end up happening is now, because we're connected by a belt, the linear velocity will be the same. So the 15 meters per second, or the 15 pi meters per 1 second times, now you can use the other one if you want, or the centimeters per minute, that would probably be the best one, but since I have this already set up, the radius of the alternator is 5 centimeters, so I'll do 1 over 5 centimeters. So now I'm about to be in angular velocity, but I got rid of let's go ahead and get rid of the centimeters and meters. And once again, there's 500 centimeter, 100. There's 100 centimeters for 1 meter. And notice centimeters cancels and meters cancel. So right now we are in radians per second. If I'm trying to get the revolutions per minute, well, 1 revolution is equal to 2 pi radians. So now we're in revolutions per second. To get 2 minutes, well, there's 60 seconds and 1 minute. So when I start canceling things out, the minutes remains. So that's okay, but the seconds disappears. And now it's just a matter of multiplying everything across. Pi's go away, and I end up with 900 revolutions per minute. And that's for the alternator. And then you can do the same thing for the water pump. It's just your radius changes. And that's it.